Okay, just to again put things in context, is this thing of solving the simultaneous equations to get a model is really a big deal. Okay? It really shows you, and it's kind of a central idea in the course. So what did we start with modeling? We started again with the pendulum experiment. And as I said last time, we've got the y equals ax to the p model. Okay? And one thing I found in looking at the homework that I got was that not everybody understood what I meant by what are the parameters. Parameters are the unknowns you get when you plug in your x and y. So I've been referring to like the y equals ax squared plus bx plus c model. I've been referring to a, b, and c as parameters. I don't know if I ever really made the statement, this is what I mean by the parameters. Okay? So, first attempt at the model, I think, was to see if y equals ax to the -1 works. Okay? There's an assignment you had early in the semester. It just means that you can take one point, one set of x and y values, and solve for a, right? You only need one data point. Plug in x and y and solve for a. We did this. You did this. Okay? And then we see if the resulting model works for the other data point. That is, we find a, we put a in here, and then we put the x and the y for the other data point in and see if the two sides are reasonably close. You don't expect them to be absolutely equal because this is real world data, and there are going to be some anomalies. We might not have counted everything exactly right, and even if we did, the -1 power is unlikely to be an exact match. Even if it should be a -1 power, it's unlikely that it really will be from your data. Okay? But if it's close, that means a -1 power is a pretty good model. Okay? So what happens with the -1 model? It wasn't so. Didn't work worth a darn. It didn't predict the second data point well at all. Okay? So see if y equals x and -2 works. Well, you go through the same process, and we find that it's even worse. It's so bad you'd be tempted to say that it's even worser. But it's worse, that's enough to say. Which means they're probably going the wrong direction with your powers. Okay? Going from -1 to -2. So what would you try next? Huh? Positive? I wouldn't try a positive number. The reason I wouldn't try a positive number is we did observe that when the pendulum got longer, the frequency got lower. okay, the count got lower. And a positive power is always going to take take it higher. So, you know, if you're in the context, you would see that, and you'd say, well, it can't be a positive power. Okay? So we're going to stick with negative powers. Now, if -1 doesn't work, and -2 is even worse, what do you think you might want to try next?
I think -1/2.
No, you're obviously going to try -1 over pi. Okay, we'll try -1/2. Yeah, that would be the logical thing because of the functions we see and because you kind of understand square roots and stuff. And okay, so and that was a good answer. -1 over pi, I'm just kidding. Okay, you never know. But anyhow, see if this works. And this turns out to work pretty well. You just go through the same process. You find A, and then you plug in your X and Y, and you see the two sides are reasonably close. Okay? They won't be exactly equal. So maybe then you try things like, well, that's a -0.5 power. Okay? And you look at what happened with the -1 and -2 and how these match up compared to the way these match up, and you say, maybe we want to try the -0.4 power. Or maybe you say, we want to try the -0.6 power. Okay? And you could go with trial and error, and you could keep doing trial and error until you come down with something. Probably the measles. And incidentally, if you have been vaccinated, unless you have some reason that you don't want to be vaccinated, you know, I had measles. Everybody had measles when they were kids in my generation. This was before there was a vaccine. Okay? We had a polio vaccine, which was good because the kid 2 houses away from me died from it. And kids were getting crippled and all kinds of stuff was happening. But you know, I just, you know, itched a little bit and had to stay in bed for a couple of days. Ran a fever. I didn't really mind. Didn't feel particularly sick. Okay, but my mom caught it from me and nearly died. Bad for adults. So hopefully you know that. Okay. So, this works pretty well. Better procedure. You get 2 points and use 2 simultaneous equations. What model do you use? What kind of a function is this?
Power function.
Oh, yeah, I was going to say either some of you are spitting, you're saying power under your breath. Okay? And since floor seems to still be dry, I guess you're saying power, right? And hopefully everybody said that. Hopefully that word echoed in everybody's mind because it's important to know what kind of function is what. Especially since, as of the midterm, you're supposed to know which of the basic functions are power functions, why, which ones are exponential functions, and you can probably guess which ones are logarithmic functions. Okay? You have to know the difference. So you're going to need to know that. Make a note of that. Okay, anyhow. Okay, using y equals ax to the p. What are the parameters? I'll give you a hint. There's variables and there are parameters. Tell me what the variables are.
Y and A.
X and Y are your variables, right? You know, you observe the thing for different X's, different lengths, and you're going to get different Y's, different frequencies, okay? So Y equals AX to the P. X and Y are your variables. So what do you think the parameters are? Well, you know, it's A and P, right? And you know we did it, you know, we've done it many times. We've solved the simultaneous equations. You have to use logs because one of the parameters is an exponent, okay, which is why we didn't immediately use this at the first of the semester until we learned how to use logs. But one of you get two equations in A and P. Solve for A and P. Then check it against another data point. Now we didn't get another data point, right? I've still got the chalk box, so I can still measure lengths, I can still suspend a pendulum, okay? So maybe we'll do that, we'll see. But you could count a pendulum. We have pendulums with length 1 and 2, 1 and 3. We could do a length 2 and see if our model works, okay? We could predict what the result would be for length 2, then we could count it, see how we do. Okay, well, you know, one danger doing that is y'all have probably gotten better with counting since then. So maybe the data is going to be more precise when you count the 2, length 2, than it was when you counted the lengths 1 and 3, right? And we're not going to take the time to count lengths 1 and 3, even though it doesn't take much time. So there are little anomalies that can come up in any modeling process, and that's kind of one of the messages I want you to carry away. Because modeling is extraordinarily important in fields, diverse fields. And you won't know until you get there whether it's going to be important in your field or not, but it's likely it will be. Okay. Okay, so we do this, okay? And that's good. Okay, so this is better. Even better? Get many points. Observe this thing for a lot of different lengths. Graph it and sketch the trend. That means you make a graph. Got enough points yet? And then you sketch a curve that you think follows the trend. The trend here is pretty clear. I drew it a little too high. Chalk just misbehaved. So I didn't draw a perfectly wonderful model. I can fix that, just put some more data points up here. There we are. Now, okay, I'm cheating. And then we know the model, or we expect. I've told you that physics predicts this model. You have to trust me on the physics. You have to do differential equations and stuff, and that's, you know, you're 2 years away from being able to touch that, okay? Even if you would decide to pursue it. But we pick 2 points on the graph. Pick 2 points. Find A and B. and then check how your model works with each point. Now that's, if you got this many points, that's probably something you're going to do with a spreadsheet. It's real easy. And you don't, I'm not going to teach you how to do that. How many of you know how to use a spreadsheet? There's an IETE course that probably teaches you some of that.
I think something like that's required for what I'm going for.
I'm sorry?
I think something like that's required for what I'm going for.
Yeah, if you're in the science curriculum, which most people that take this course are, or the business curriculum, you got to have it. Okay? Business or science, you need this course, you need an ITE course. And that's, you know, many of the main applications are in those areas, but, you know, even for the social sciences, psychology and stuff, to understand data and understand what the things you are measuring are telling you, you need it. Okay? So it goes a little further. You would just go down all your data points, take your X values, predict what your Y values ought to be, and see how different they are from the point that you are looking at. You do that for all the points, you average how much different they are, and you get an idea if your model's very predictive, okay? Now there's much more you do with it, and you learn that in the statistics course, which is also something that's everybody should have, okay? It's the easiest of your math requirements, okay? So almost everybody who takes this course also has taken or will take statistics. If you've taken it, you understand a little bit about what I'm telling you, okay? And you learn how to use the software. I'm not interested in teaching you how to use the software, because if you understand the mathematics, using the software is something you pick up in 30 seconds, okay? And it just distracts from the mathematics if you're relying on the software. So I don't do that. So anyhow, this is what we got, right? And that's an overview of the modeling process in terms of the pendulum. You have a simple model that gets you pretty close. You have a better model using 2 data points, okay? Then you can use all the data points. And of course you have regression. Excel does regression. Any software package does regression. You can do power function regression and just do it with a click of the button. Here you learn to understand what that means. There, you know, you act like an engineer, you just get the right answer. Now, I'm not knocking engineers. They have a different orientation than scientists. They actually make things work. I don't understand why they would want to do that, but they do. Okay.